And in this framework, it's my pleasure to welcome Paola Manoni from the Biblioteca Apostolica Vaticana, who will be speaking to us shortly. The collaboration with the Vatican Library is an important element in this year's program, and your presence therefore greatly appreciated. I do hope that it will be possible to keep in touch also for future initiatives. Let me present Paola briefly to you. Paola Manoni is the head of the coordination of IT services at the Biblioteca Apostolica Vaticana. Her research work area is focusing on metadata, digital libraries, interoperability protocols, and long-term preservation for cultural heritage. She is the chair of the UNI Technical Committee Documentation and Information, and also of its subcommittee Technical Interoperability. She represents the Vatican Library in many international initiatives, such as the IIIF Consortium, and in this context, she is also co-chairing the IIIF Discovery for Humans Working Group. Today, she will be speaking to us about the digital workflow and the IIIF initiatives at the Vatican Library. Please do welcome Paola Manoni. It's a pleasure having you.
Thank you so much for your presentation, and thank you for inviting me. It is my pleasure being with you today. So, yes, I would like to talk about the digitization project of the manuscripts of the Vatican Library, with particular regard to the initiatives undertaken for the long-term preservation of digital manuscripts, as well as to the use of the International Image Interoperability Framework. I don't know if you are familiar with the IIIF protocol. Okay, this is great. But first, let me give you a brief introduction about the Vatican's collections of manuscripts. The Vatican Library, in the moment of its foundation, was perceived as a humanistic library and preserved its character during centuries to come. Pope Nicholas V, around 1451, decided to make his Latin, Greek, and Hebrew manuscripts available for the common benefit of learned men. And today, the library is still in service of learned men and women, having evolved during its long history into a modern research library, preserving important collections which constitute an essential part of the cultural heritage of mankind. The creation of a universal library open to the public was the original purpose that expressed the humanistic idealism of the age of Nicholas V. We can say that today, the implementation of a universal digital library at the Vatican is the challenge of our times. The Vatican collection of manuscripts, excluding archival units, I'm referring to the codices, the books, not the archival papers, is composed by roughly, moreover, 80,000 codices, mostly from Middle Age and humanistic period. The manuscripts called Latin, namely those written in the Latin alphabet and also in several languages such as Latin, Italian, French, English, Spanish, German, Provençal, and many others, are about 62,000. About 5,000 are written in Greek alphabet, while 920 manuscripts are in Hebrew, apart from a recent acquisition, a very rare acquisition, an unknown one, of about 100 of manuscripts. In the Vatican's Oriental collection, there are more than 9,000 manuscripts. The languages these manuscripts have been written in include Arab, Copt, Syrian, Armenian, Ethiopian. 2,000 codices are rare works pertaining to Chinese, Korean, Japanese cultures. This wide collection is accompanied by a considerable number of early printed books. These books include nearly 9,000 incunabula and tens of thousands editions from 16th century. Aside from 1,600,000 printed books, the collection also includes over 300,000 coins and medals, 150,000 prints, drawings, and engravings, and over 150,000 photographs. The ambitious digitization project aims to digitize the entire Vatican collection of manuscripts at first. For a brief retrospective note, the year 2012 marks the beginning of the digitization project, precisely when in the Vatican Library the preliminary study began in 2010 the adaptation of the data center for holding the long-term preservation system of high-resolution images. Digitization should be carried out as much as possible once and for all. This is because such an undertaking requires a huge investment in terms of both costs and time, so much so that any attempt to begin again would be unreasonable. As is evident and proven by its long history, the library is continually committed to preserving the manuscripts and all its holdings with all due attention. This is done by respecting the parameters universally provided in this regard, and by avoiding any action which may cause any damage to the items. Therefore, organizing the digitization also means preventing any damage, however slight, as much as possible. This is why, prior to digitization, the workflow requires that the volume's conservation status be checked. In light of this assessment, either the digitization is ruled out if dangerous for its preservation, or special scanners with cradles are used, opening the volume to a maximum of 110 degrees. Moreover, the state of conservation of each volume is described and gathered into a database, and if necessary, a restoration of the fragile parts takes place. After the digitization and before the volumes are rearranged, the state of conservation is reassessed and it is compared to the previous assessment. The IIIF system in which the digital data are stored is structured in a staging environment in which images, once generated by the scanners, are ingested and reviewed by tutors in order to evaluate the quality of the work done. Once a digital object is validated, it is moved to evaluate, after the evaluation, it is moved into a certified environment. Here, the high-resolution image folders corresponding to the digitized volumes are automatically processed. On the one hand, for the ingestion in the long-term storage archive, and on the other, for conversion into the derivative format for the web dissemination. But before describing the subsequent steps, it is useful, albeit briefly, to illustrate a peculiar and important detail relating to the aggregation of images for the composition of virtual volumes. Each high-resolution TIFF image is named according to a method that sees that file names as a structured set of information. There are codes which distinguish sequences and which handle foliation exceptions, which are typical of manuscripts material. These exceptions, included in the file name, are stored in the database set up according to the premise schema, with all the information that keeps tracks of the event for the purpose of the long-term preservation. Thus, these foliation characteristics can be quantified and identified in order to allow further codicological analysis of the manuscript materials. Furthermore, again according to the premise, all the information relating to the conservation of the digital items ingested and the related actions undertaken are searchable. So this is our premise database, a database compliant to the premise, in which we can look for any images in terms of each event happened during the process and also after. So beyond the trace of all conservation events that is managed according to premise, the key element of the Vatican Library's long-term preservation is the choice of the storage format. After the validation and certification procedures, each TIFF file whose quality has been validated with the use of the well-known Jove API is converted into the FITS format, and in this format, it is further validated by a parser that checks the quality of the conversion. The FITS format, developed in the late 70s of the last century in the context of astronomy and space missions for the storage of satellite images, is an open, fully documented, royalty-free, copyright-free format based on a series of publicly available specifications and managed by a non-profit scientific authority. The FITS format respects one of the key principles of long-term archiving, namely the use of a portable and self-descriptive format, assuming that, apart from the transcription device, neither the software nor the hardware that brought the data could be available when the data will be read in the future. It is also fully satisfies the 7th principle of sustainability summarized by the Library of Congress. A FITS file is made up of 2,880 byte records called FITS blocks, divided between a header and a data area. The main feature of the FITS format is that the metadata of the images are stored in a readable ASCII header in order to ensure the immediate identification of its origin. Each FITS file can be characterized by one or more ASCII headers, so it's a multi-dimensional file. Fixed length strings of 80 characters that encode keyword value pairs interspersed between data blocks. The keyword value pairs provide information such as dimensions, origin, coordinates, binary data format, free-form comment, data history, and any other metadata you want to freely define for single units or collection of images. In fact, apart from the use of predetermined keywords, the standard allows an arbitrary use of local elements. The data of the header portion of the fits image file is further replicated in the previously mentioned premise structure. This means that all information relating to the constitution of the digital object, such as acquisition, conversion of images, ingesting into the long-term archive, are recorded, indexed, and therefore easily retrievable through a search graphic unit interface. I would like to resume now the phases of the workflow that occur after and in parallel with the long-term archiving. I mean, after the certification of the quality of the master copies. We can say that similarly to what happens for the flow described for the ingestion of digital objects for the purpose of long-term preservation, another pipeline is able to trigger the conversion of images into the derived format for the web, the JPEG 2000 format. Once the conversion of the JPEG 2000 files is completed, the phase of associating the virtual volumes to the related descriptive metadata coming from the catalogs is carried out, as well as with the production of structural metadata for the table of content lists linked to images. All the aggregation of this information is managed according to the METS standard. From METS files, the production on the fly of IIIF manifests in JSON format is made available. And now I would like to focus on the International Image Interoperability Framework and the Mirador viewer through the use case of the digital manuscript collection of the library. The IIIF, as an interoperability protocol for image resources held in libraries, archives, museums, has produced over 1 billion IIIF compliant images. I would like to consider, before presenting our use case, the concreteness of this production and also focus on how this vast production is actually changing not only the use of digital objects online in the context of tools at the convenience of digital humanities, for instance, with the well-known abilities of IIIF viewers such as Mirador, but also the concept of discoverability of the knowledge objects now available via IIIF. Discoverability is the quality of being able to be discovered or found, and in relation to online content, it is the quality of being easy to find via a search engine, within an application or on a website. If we focus on the discoverability in the IIIF context, we can refer to two main aspects, which are the requirements that make a web platform a discoverable digital library service in the light of the IIIF, and how it is possible to discover IIIF compliant content through current web platforms. A first look about the contents of the two issues is concerning the non-trivial meaning of libraries, archives, museums, data in the universe of a single domain for an evaluation of their impact on the discoverability of IIIF objects. We thus consider the abstraction of LAM data produced within the digital ecosystem starting from the traditional statement related to the classes of the structured data. In the line domain, they include the bibliographies, indexing and abstracting databases, citation indexing, catalogs of all kinds, special collections, portals, metadata repositories, curated research datasets, and name authorities. Structured data are typically held in databases in which all key value pairs have identifiers and clear relations and follow an explicit data model. While semi-structured data in the LALM general context are the unstructured sections within metadata description. For example, the rich content description contained in archival finding aids, table of contents and abstracts of reports in digital repositories, digital finding aids, intellectual works encoding following the text encoding initiative guidelines, or any unstructured portion of otherwise structured data sets. And then we have unstructured data characterized as everything else. In LAMs, they can be found in documents and other information-bearing objects, textual or non-textual, digitized or non-digitized in all kinds of format. In data resources that are served through LAMs, unstructured data are usually available in the largest quantity in comparison with structured data. And they have most diversity in type, nature, and quality, and are the most challenging to process. So now let's consider the typical elements of the IIIF presentation API, keeping in mind that the IIIF presentation API provides a model for describing digital representations of objects, just enough metadata to draft a remote viewing experience. And it provides a format for software, viewing tools, annotation clients, websites to consume and render the objects, and any other associated content in the form of annotations. This doesn't mean that the descriptive metadata has no place in a digital object delivered by the presentation API. Conversely, it is important that the object is accompanied by useful information and links to other description of the object. The presentation API takes a great care to ensure that you can accompany your digital object with rich human readable descriptions. Sorry, it was the previous slide. With support for multiple languages, so that viewers can display that important contextual information to users. It also provides an explicit mechanism for linking to one or more semantic descriptions of the digital object depicted, as well as relating human-readable resources. The information pertaining to presentation API is the IIIF manifest of the digital object represented as a thing and enriched with the complex knowledge data related to it. A so-called IIIF manifest contains a descriptive section of the digital object, but the specifications do not define any rules relating to metadata. In other words, we can say that IIIF requirements are completely agnostic as to which descriptive metadata to apply, as well as to which image formats. The galaxy of data pertaining to the thing represented in the manifest is completely scalable and referable to the different meanings of LAM data, The structure, semi-structure, and unstructured we mentioned. Moreover, as for the presentation API, the meaning of any accompanying descriptive metadata for displaying a viewer is irrelevant. The API's job is to get the content of the work, for example, the pages of the book, the painting, to a point where a human can interact with it in a logical way, to view it, read it, annotate it, mix it up with other things if they want. A IIIF client can also display any accompanying metadata included as multilingual pairs of labels and values. But that's as far as it goes. It needs no definition or scheme for what that metadata means. It is outside of the scope of the presentation API. The user can view important semantic metadata, but the presentation API is just a conduit of that text. In the presentation API, those strings have no semantic significance. They are not defined in the specification. A client of the API should just render them. If an end user wants to know what they mean, he may look at the link to descriptive metadata that a publisher or a IIIF resources provides. In a nutshell, a manifest is what a IIIF viewer loads to display the object. A manifest could be used to generate a web page for the object. Manifest could be also loaded into an annotation tool or a IIIF editing environment to be used as source material in the creation of a new manifest. The structure of the manifest also includes the concept of sequence, which is of fundamental importance for aggregated resources, for example, books, manuscripts, and archive materials composed of page, leaf, folio, sheet, and canvas. Each view of the object, for example, each page, is represented by a canvas. A manifest contains one or more sequences of canvases, but a canvas is not the same as an image. The canvas is an abstraction, a virtual container for content. The concept of a canvas may seem like an extra layer of a complexity. It's not much more complicated to do in this way, but it is much more flexible and powerful. The canvas keeps the content separate from the conceptual model of the page of the book or the painting or the archival unit. The content can be images, blocks of text, video, links to other resources, and the content can be positioned precisely on the canvas. By including a canvas in a manifest, you provide a space on which users and scholars can annotate content. All association of content with a canvas is done by annotation. The IIIF presentation API, in fact, is built on the open annotation standard, which has now become the W3C web annotation data model. At its simplest, the web annotation data model is a formalized way of linking resources together. An annotation is considered to be a set of connected resources, typically including a body and a target, and combines that body is related to the target. The exact nature of this relationship changes according to the intention of the annotation, but the body is most frequently somehow about the target. This perspective results in a basic model with 3 parts depicted in this slide. The full model supports additional functionality, enabling content to be embedded within the annotation, selecting arbitrary subcomment of selecting arbitrary segments of resources, choosing the appropriate representation of a resource, and providing styling hints to help clients render the annotation appropriately. The canvas establishes a stage in which the simplest case, 1 image per canvas, is straightforward. But more complex cases, more complex and interesting associations of content can be managed. We can argue at this regard that the semantic enrichment process pertaining to the IIIF's vision of LAM objects and the data reflects the broader general transformation from document-centric to entity-centric knowledge modeling due to the many relations for each canvas. Let's now go back to consider the discoverability of the IIIF in the light of Presentation API. And the first question, which are the requirements that make a web platform a discoverable digital library service in the light of the IIIF? So I would like now to focus on this by taking the use case of the Vatican Library as an example. The DVL, the DigiVatlib, is a digital library service. It provides free access to the Vatican Library's digitized collections, manuscripts, incunabula, archival materials and inventories, as well as graphic materials, coins and needles, printed materials. As said, it is fully based on the IIIF technology, making digital materials easy accessible and usable. The viewer is able to zoom, browse, and turn pages of JPEG 2000 images, as well as to allow scholars to compare digital objects from different IIIF repositories of other digital libraries. Descriptions and bibliographic references from the online catalogs are indexed and linked to digital materials. Each object is equipped with URIs for the discovery of IIIF manifest. The guided navigation facilitates search, leverages metadata elements for narrowing or refining queries. Moreover, I would like to focus on the use case of annotations in IIIF as part of the 3-year Melon project held between 2016 and 2019 in conjunction with Stanford University Libraries, which produced over 26,000 annotations for a selection of manuscripts chosen in the context of thematic pathways. In this platform, the content of all the annotation is indexed along with the metadata, thus constituting a semantically enriched system that allows scholars to query an integrated search of all the available content of a resource. The project aimed to demonstrate, among the advantages of the IIIF for manuscripts, how the annotation level is a fundamental innovation for the study of contents, transcriptions, comments, comparative analysis of texts and images. Thanks to the funds received, the library has implemented a workflow to enrich the digital delivery of these materials by annotating some exemplary manuscripts using Mirador with scholarly analysis in order to tell scholarly narratives that provide interpretation for the individual works and illustrate important aspects of the world's pre-print culture. I mentioned Mirador. Mirador is a fully IIIF compatible tool capable of interpreting IIIF APIs. Mirador, as you know, is an open source image, JavaScript, and HTML5 viewer that delivers high-resolution images in a workspace that enables image annotation and comparison of images from repositories dispersed around the world, starting from compatibility with the Image API that specifies a web service returning an image in response to a standard HTTP or HTTPS request. Mirador has been optimized to display resources from repositories that support the International Image Interoperability Framework APIs. It provides a tiling windowed environment for comparing multiple image-based resources, synchronize structural and visual navigation of content using OpenSeaDragon, Open Annotation, Open Annotation, compliant annotation creation, and viewing on deep zoomable canvases, metadata display, book reading, bookmarking, and more. Mirador is developed as an active open source project that regularly receives contributions from software developers around the world. Several large projects sponsored by peer cultural heritage institutions regularly meet and coordinate the development of new features and releases that benefit not only their individual projects and institutions, but also the community more broadly. Mirador back to the Web Thematic Pathways project. The Vatican Library intended to engage the visitors to its website on the possibility for using annotated manuscripts in IIIF according to specific themes by providing tools for discovering and comparing digital materials. The deep analysis of contents of manuscripts entail the understanding of the preprint world in which the manuscript is born. This implies a knowledge pertaining to the history of the manuscript, its origin, provenance, as well as other circumstances of the production of a manuscript, identification of dates, scribes, artists, discussions about the intellectual content, and descriptive discussion on paleographic matters. In its essential lines, a thematic pathway is composed by 3 different kinds of information: a general description, introduction, historical information, so on, of the chosen theme, and it represents the story. Descriptive and structural metadata, and a curatorial narrative for each manuscript. And annotations, comments, in-depth analysis about detailed part of a manuscript, and transcriptions of units of information. Now I introduce the 4 thematic pathways we have developed. The first one is about courses in paleography, Greek and Latin from antiquity to the Renaissance. The rich collection of manuscripts preserved in the library makes it possible to follow the evolution of the Greek and Latin scripts all the way from antiquity to the Renaissance. A careful selection of images of manuscripts accompanied by transcriptions and comment, could be very useful as teaching material for a course in Greek or Latin paleography. The availability of online images of manuscripts, together with the possibilities offered by the IIIF APIs, allows a complete transformation of teaching practice in this field. The explanatory materials, the story, which frames this unit, can be thought as a sort of textbook. For each of the sections, the Greek and the Latin ones, of this thematic path, we have a set of complete digitized manuscripts chosen to illustrate the phases, the mouse, yes, it was these slides, the phases in the development of the script from the 4th to the 16th centuries. From each manuscript, chosen pages with a paleographical and a codicological description and a diplomatic transcription is also made available. The second thematic pathway is about the evolution and transmission of texts of specific works, the Latin classics. The Vatican Library owns one of the most important collections of manuscripts with texts by classical Latin authors, many of them richly illustrated. The aim of this pathway is to describe 81 manuscripts directly from the original codices. Metadata and annotation pertaining to the study of texts and illumination have been provided. The work throws light not only on the illustration of the text, but especially on the relationship between text, illuminations, comment, and gloss. The importance of this project lies in the remarkable variety of typologies of the classical world, from epic, lyric, and elegist to dramatic, philosophical, historic, and declamatory. I'm fighting against this mouse. Each manuscript has been selected in order to reconstruct the figurative imagery of the classics from papyrus style, the illumination set within the text column, to historiated initials. In addition, these selected manuscripts present particularly interesting textual and historical characteristics because the classical authors continue, even today, to provide paradigmatic images and concepts. Classical authors, in fact, have always received special attention due to their ageless modernity. The third path is about Vatican Palimpsests, the digital recovery of erased identities. The Vatican Library has identified more than 380 manuscripts in its own collections, which include palimpsests, erased and then recycled parchment folios. This pathway intends to present this rich and scarcely explored material to the public, but by making an in-depth archaeological research on the palimpsests of 24 select manuscripts and recover their lost identities with the help of IIIF technology. Making accessible, hardly legible images to the public is a challenging task because the actual method of publication has been designed to typical objects. Thus, publishing online atypical objects require creative solutions and improvements of the actual routine. By the pathway, digital reconstructions makes for palimpsests accessible by their upper and lower script, a condition with the actual conservation of these manuscripts and the normal method of publication do not allow. These manuscripts include, for example, the only surviving text of Cicero's Republic, 4th, 5th century, and the earliest but so far neglected manuscript, 9th century, of Philo of Alexandria, who combined Greek and Jewish philosophy in Augustus' time. The lost identities of the select manuscripts cover the history of Latin and Greek scripts from 4th, 5th century and embrace a wide range of cultural contexts before the 12th century, mostly of the Byzantine world, and shed light on the history of textual scholarship with them. Erased texts are often very old and significant witnesses of a lost past, but they are difficult to access for the naked eye. They need an expert interpreter and highly special photographic and post-processing technologies, and especially the flexibility of presentation offered by IIIF APIs can turn erased text more accessible online than in their physical existence. By doing so, the pathway creates an innovative method of presenting palimpsests of the Vatican Library compared with the actual routine of digital presentation of Vatican manuscript and to the online presentation of the palimpsests elsewhere. I can add also that we study a kind of theoretical JSON manifest. Why theoretical? Because in nature, the reconstruction of the inner scripts divided into different folios is not available. In nature, I mean, in the codices, in the codex. So we have taken the different piece of canvas. So we have described a theoretical sequence of canvases reconstructing the inner folio, the inner scripts within folio. The last path is very different from palimpsest, is about the Humanities Library of Federico da Montefeltro in Urbino. The Library of Federico da Montefeltro, Duke of Urbino since 1474, is known as a typical humanist collection. Well-represented sectors include scripture, patristics, theology, classics, contemporary technical and scientific works, and contemporary literature. The most common language is Latin, but Greek and Hebrew are also represented. The collection was outstanding not only for its substance, the amount of volume, as well as the quality in relation with other libraries of that age, but for the value of each manuscript partially acquired from antique market, many commissioned by Federico, and realized by refined copyists and greater artists of that time. The manuscripts were produced in two main locations, Florence and Urbino. In the first years, Federico preferred to buy or order manuscripts in Florence, both in writing and in illumination. Later, he preferred Ferrara or Paduan artists and scribes active in Urbino. This pathway points out the characteristics of the two schools, very different in style, and the most important artist, half of the chosen manuscript is representative of the Florentine school, while the other half of the Ferrara and the Paduan schools. Again on Mirador. Mirador development for this project has contributed to and benefited from this community development effort. Throughout the course of this project, Stanford's technical team has actively engaged in Mirador's community-based development process. This has ensured development work for the Vatican Library dovetails with enhancement planned by other parties, and that features for the library has been integrated into the core code base and correspondingly maintained by the community extensively, an important sustainability strategy. So, in a nutshell, thanks to this project, we have now in Mirador the possibility of polygonal shape of annotations as well as irregular shapes, just this, or enclaves of annotations. I mean, an annotation within another one and within another one, typical for when you have to transcribe a text. So you have a grid of rows. Each row is an annotation, and within this row, you want to emphasize some details, for instance. For the purpose of the Thematic Pathways project, Mirador's functionality has been enhanced and support better scholarly markup. Desired feature for creating and editing annotations during the scholarly analysis of the project manuscript have been grouped into extensions of annotation creation capabilities and extensions of users' ability to work effectively with the body of annotations once they have been created. For the extension of annotation creation capability, specific areas of development have included the ability to create right to left, left to right, vertical and multi-directional annotations in order to respond to various linguistic and layout needs in the corpus of manuscript to be analyzed. Support for left to right, right to left and vertical navigation of manuscript materials in the viewing windows of Mirador. A stable platform for the creation of annotation on complex region of interest. Again, a stable platform for the editing and deleting of existing annotations. The ability to credit an author or a group of authors for each annotation. Ability to provide layout formats within the body of an annotation to support footnotes and bibliographical citations. And support of all Unicode character in the body of annotation. The described and annotated manuscripts presented in Mirador within each of the thematic pathways are published online as an exhibit in the Spotlight, that is an open source software that enables librarians, curators, and other content experts to easily build feature-rich websites that showcase collection and objects from a digital repository, uploaded items, or a combination of the two. A Spotlight exhibit can be created by librarians, curators, archivists, and others who are not web developers. Spotlight can interoperate directly with the digital repository, enabling seamless population of the exhibit with digital objects and their metadata. IIIF annotations, such as this. So this page is a kind of web page in this Spotlight system, directly coming from the Mirador. So in the pipeline, there is the manifest interpreted by Mirador. In Mirador, curators a curator has annotated a folio within a digital object. the digital object has been indexed along with its metadata in the Spotlight, and the Spotlight is able to interpret in a page as well as to query directly from the content of the annotation with all the other enriched contents composing the pathway, composing this kind of exhibit. Annotations are also classified using tags. This is on the left part of the screen, a list of tags, for instance. Tags for the classification of topics and the identification of personal names. For example, the names of scribes, illuminators, and places, geographic names, such as the provenances, according to the authority file of the library. Tags are available as authority lists in Mirador for each thematic pathway and then indexed as searchable in Spotlight, as I said. We have identified over 900 tags pertaining to topics, while names, personal and geographic names, are established according to, as I said, the authority files of the Vatican Library. In some cases, we have also identified hierarchical relations of tags, such as themes related to illumination to display as hierarchical facets. Tags are available in English translation, being part of facets and indexes in Spotlight. Finally, I would like to mention the current work of the Mirador community. I refer to the implementation of Mirador 3. Mirador 3 as a highly configurable, flexible, next-generation version of the interactive IIIF image viewer capable to enhance full-text annotations, annotation attributes, such as tags, author, motivation, story-oriented annotation, in which annotations drive the navigation within and across canvases, related to digital objects to be read right to left, as well as left to right, and multi-scripts metadata. This shows that the revolution of the image-based resources is not yet over, and new challenges for the growing IIIF community are still ongoing. As said, the IIIF enables the creation of rich digital collections that bring together content distributed among cultural heritage institutions. With image viewers, one is able to analyze works held in physically different locations side by side or overlaid within web browser. However, in order to take advantage of the research tools afforded by IIIF, a user must be able to find IIIF resources. This is a great dilemma, because we have millions of images IIIF compliant, but we do not have, so far, a kind of indexation of where they are. I mean that we can discover resources IIIF compliant in the Vatican Library, in British Library, in the Fragmentarium in Switzerland. But apart from, I don't know if you are familiar with this project, Biblissima. It is a sort of attempt for gathering information and for indexing URIs of JSON manifest. We do not have a control, we can say this. We do not have a control of the complex information we have in the web. I mean, we do not have a kind of search engine capable of discovering IIIF materials. So this is the great dilemma we are considering in the Discovery IIIF Discovery for Humans work group I am co-chairing. But again, interoperable objects are of no use if one cannot find them, particularly if relevant objects reside in servers in many different institutions. Discovery in this case means human searching, browsing and finding out IIIF resources across institutions. To be successful, IIIF Discover must be user-focused and meet defined user concrete needs. So, how it is possible to discover compliant content through current web platform, which is the question, the threat I want to underline this talk. Thank you so much for your attention.